All right, it's the Molecube. I really like this puzzle. It turned out to be something quite different from what I thought I was getting when I got it. Take one look at it, and clearly it's mechanically a Rubik's Cube. You also take one look at it, and one drawback of it is it looks like it's scrambled when it's solved. This puzzle is currently in a solved state. But, of course, the idea with this is instead of 6 colors, you have 9, and you want one of each color on every side. And so it has this tendency to look like it's scrambled up even when it's solved. But that's okay. It's like I said, it's a fun puzzle, and I've enjoyed doing it. I thought when I said it wasn't what I thought it was going to be, I thought I would get this thing home and then I'd have to kind of build out a big spreadsheet and kind of figure out what the solved state looks like, and then use my, kind of Rubik's Cube techniques to get me to that solved state. What I found in the process of taking it apart is that the solved state is not unique. This is a solved state, but there are multiple different solved states, and that's pretty clear. Once you start messing around with it, that there's not just one way to put this thing together. It turns out that there are 80 different solved states for this cube. I'm not the only guy that can teach you how to do it. There are certainly other videos out there with solutions for this. Why am I contributing mine? Most of the solutions that are out there, if they move at a sort of beginner's pace like I like to do, a lot of times what they come with is they give you the solved state and basically say, all right, here's what it's going to look like when it's solved, and then kind of gives you the Rubik's Cube treatment of how to get you there. And that's the part I'm not crazy about. To my way of thinking, you can put the solution together on the fly. You're just not going to do it with your standard Rubik's Cube solution. If you're familiar with the Rubik's Cube solution, and you don't have to be, I'll teach you how to solve this thing whether you know how to solve a Rubik's Cube or not. But if you're familiar with the Rubik's Cube, you solve one side, then you flip it over, and then you work from the bottom up. And if you do that on this cube, you are almost invariably going to run into problems in doing it. You're going to get yourself into an unsolvable state on the way up. And I found this out myself through several iterations of trial and error. And what I want to do is give you a solution where you can find the solved state. You do not have to have a sort of pre-mapped destination in mind. I'm going to take, instead of a solve it from the bottom up like a Rubik's Cube, I'm going to solve it from the outside in. I'm going to start on the corners and then do the edges. And the reason that we do that is I found in my failed attempts to solve it like a Rubik's Cube, it was the corners that were most frequently the problem. And the edges are considerably easier to move around. And so what we're going to do is we're going to line up all the corners in a way that a solved state is possible, and then move the edges around to get us there. All right. So before we go any further, a little bit of anatomy of the cube and talk about the different colors and introduce an important piece of terminology we're going to use. There are 9 colors again, and you see them all here. 6 of those colors are in the centers, and each one of those center colors also has a corner. Here's a yellow center. Here's a yellow corner. And here's a yellow edge. Again, every one of my 6 centerpieces is going to have a corner and an edge of the same color. So those 6 colors are white, light blue, black, dark blue, yellow, and orange. Try to future-proof this video as much as possible. I can't rule out the possibility that somebody might make this cube with different colors than the ones you see here. But this is the color configuration on my cube. It's also consistent with the other ones I've seen on the internet. So I think these colors are pretty standard, but if those 6 colors in the centers are not yours, you'll have to interchange your solution with whatever those colors are. So there's my 6 colors that are in the centers. I got 3 other colors. I got red and purple. With red and purple, each of those has 3 edge pieces. Purple edge, purple edge, purple edge, red edge, red edge, then finally, the last color is green. I got 2 green corner pieces. Take a look. Holding this with a kind of a pyramid, with the point of the pyramid facing toward the camera. Every cube of any size has 8 corners. Here's 1, 2, 3, 4, 5, 6, 7. So if the idea is that no 2 pieces of the same color can share a side, well, look at this. This shares sides with 6 of the other 7 corners. The only way that the greens can be configured in any solved state is if they're on opposite sides of the puzzle. This is the only way that the 2 greens can coexist in a solved state. Imagine the puzzle is like a piece of taffy and you're pulling it apart. Here's what we're doing. Green on the far opposite corners of the cube is the only way that this can work. All right, one other piece of terminology that's going to be important here. These center pieces, I've got them organized into what I call color pairs, and the idea of a color pair is going to be important in finding our solved state. The color pair is that centerpiece and the centerpiece on the opposite side. So dark blue with light blue is a color pair. Yellow and orange is a color pair. Black and white is a color pair. All right, let's get to scrambling this thing up so we can get to seeing how to solve it. Okay, here I've got a scrambled up cube. Again, the solution here is going to involve aligning my corners and centers in such a way that a solution is possible. And so let's go over these 5 rules. I'll put them up on the screen. 5 rules for what I'm going to observe in any solved state. Number 1, I can't have 2 pieces of the same color on the same side. Well, obviously, right? The solved position has 1 of each color on each side, so I can't have 2 of the same. So what that means, if I want to start on this side with white, for instance, this and this, the center and the corner, is a problem. I'm going to have to get the white out of here. The center and the edge is not a problem. I'm going to deal with the edges later. So don't worry about the edges in this process of finding a solved state. This thing's got to get out of here, so let's move it out. All right, done. Second rule, on every side, the centerpiece is accompanied by its color pair. Black and white are a color pair. So I got to make sure that that exists, and here it does. All right, no problem. Third rule, in the solved state, at least one side, it doesn't have to be the first side you do, but at least one side has the green, the center, and the color pair across a diagonal. I'll usually configure it like that on the first side because I know I need at least one side to be like that. But for instance, if I had like this, green, white, and the color pair, but they're not on the diagonal. It's okay to have one side like this. It's okay to have 2, 3, 4 sides like this, but all sides can't be like this. At least one side has to have them on a diagonal. And so, like I said, I'll usually set the first side up like that. Okay, so right now my first 3 rules are satisfied by this. So the second 2 rules, I'm going to have to, or the last 2 rules rather, I'm going to have to flip over to see what else is going on. So green, again, we said the greens have to be in opposite corners. So if it's not, just rotate it around so that your greens are on opposite corners. I don't even have to look at what's on this side. If my first side matches up those first 3 rules, the second side will as well. So then the last thing I got to do to try to get to a solved state is take this center layer and try to move it around so that every center piece has an accompanying corner piece. So light blue with dark blue is good. Yellow is not with orange, so let's move it. Light blue with dark blue, yellow with orange. This is a problem because yellow is on the same side as the corner, so this won't work either. And this is, if you need to know that what you're doing is heading toward a solvable state right from the start, you're in the wrong place, because my method does take a little bit of trial and error. So this one is a dud. I know that I'm not going to be able to get to a solved state with the corners where these things are, so I'm going to have to start again. So I'll just do a quick scramble. Half scramble, since it wasn't really solved in the first place. Let's try this again. Light blue, dark blue. Let's move green over to the opposite corner, so I got those three on a diagonal. Get my greens on opposite corners. And let's rotate the center layer around, see if it works. I got yellow with orange. I got white with black. I got orange with yellow. And black with white. So far, so good. Now I just got to check my last rule. My last rule is my color pairs. I can't have both halves of a color pair on adjacent corners. So meaning white, the white corner can't be adjacent to the black corner. A cross on the same face is fine, but white and black can't be here and here. Can't be here and here. So white and black are not adjacent. Check my other color pairs. Orange and yellow are not adjacent. So far, so good. Light blue, dark blue is all the way over here. That works too. If you have two color pairs on adjacent corners, your puzzle cannot be solved from that condition. As it is right now, though, we've got this thing in a solvable state on my second try. I don't know what it is on average. I'd say on average, I'm probably 3, 4, 5 tries before I get to one where it can be solved. And so if you do this a couple times, if it takes 10 times to get to a solvable state, don't worry about it. That happens. But again, I think the virtue of my solution is that I don't have to start with a kind of memorized predisposition about what the thing is going to look like in the end. I just have to set up all my corners and centers in a way that I know that it can be solved. And from there on, everything's going to take care of itself. So from here, the corners and the centers are not going to move. Everything I do from here on out is going to leave all the corners and centers in the same place and just move the edges around to get to the solved state. So I will kind of give you the sneak preview. I'm going to cut this video off here in a minute, but I'll give you the sneak preview of what that's going to look like, because I only need you to know one algorithm, one sequence of moves to solve this cube. And if you know how to solve a 3x3 Rubik's Cube, you already know it. So here's a 3x3 Rubik's Cube. And on a Rubik's Cube, this is usually the last thing you do. In my solution, this is going to be the only thing we do. The last thing I do is when I have everything solved except for 3 edge pieces. I got this one, I got this one, I got this one, and they all need to move around. In this case, this needs to go here, this needs to go here, and this needs to go here. I'm going to do that over and over again on my Molecube until I get my edges into the right place. And in the next video, I'll show you how to do that, show you one thing kind of analogous to what they'd call a parity error that you might run into. But I'm just going to do this sequence over and over again. If you don't know it, don't worry about it. I'll teach it to you at the top of the next video. But there you go. We got it all set up for our Molecube. It's in a solvable state from these centers and corners. If this is working for you, if you are getting somewhere with this, feel free to like and subscribe. And if not, feel free to leave me a comment. Try to get it sorted out. So like I say, we'll clip this one here, go to part 2, where we will show you how to actually go from here to a solved state.